Let's now find our 6 trigonometric functions. If negative 2 comma 5 is a point on the terminal side of angle theta, we want to find the exact value of each of the 6 trigonometric functions of theta. Alright, I would start with a quick little drawing, something like this, drawing the point negative 2 comma 5. Note that that is in the second quadrant, and that has important in terms of the signs. Now, what I would do is draw a quick little triangle with respect to angle theta. You see theta here, but what we've learned about reference angle, we know theta prime is right there. Because that's so jammed up, let's go ahead and write theta prime here in our enlarged triangle. We know that this value right here is a negative 2, the bottom or the base of our triangle, and 5 is the height. And now we need to use Pythagorean theorem to find that, and we know that a squared plus b squared is equal to c squared, so we can say 5 squared plus a negative 2 squared is equal to c squared. And from this we obtain c squared is equal to 29. Taking the square root of both sides, we obtain c is equal to square root of 29 plus or minus. So more importantly, we'll put in the plus since our distances cannot be negative. Now that we have our triangle, we can find our 6 trigonometric functions. I'm going to start with the sine here. We know that the sine of this angle theta, and again using the reference angle it's the same thing here because we have our sines addressed with the negative 2. The sine is the opposite over the hypotenuse, which is 5 over the square root of 29. And we need to rationalize this by multiplying top and bottom by the square root of 29. And so from this we're going to come up with a value of 5 square roots of 29 all over 29. So that is now our sine value, sine of theta. Okay? Now let's find the cosine of theta. Remember that the cosine of theta is equal to the adjacent side all over the hypotenuse. And again, focusing on a reference angle theta prime, we have negative 2, the adjacent side, all over the hypotenuse, which is square root of 29. And once again, we want to rationalize our answer, multiplying top and bottom by the square root of 29. From this, we come up with a negative 2 square roots of 29 all over 29. Alright, so there is our cosine value. And then finally here, we want to find the tangent of theta. Remembering that the tangent of theta is equal to the opposite over the adjacent. And for this problem, that will be a negative 5/2. Now that we have our initial trigonometric functions, let's find the last 3. Now before we rationalize, we had the sine of theta is equal to 5 over the square root of 29. Similarly, the cosine was negative 2 all over the square root of 29, and that the tangent was equal to a negative 5/2. Now remember, there's a reciprocal relationship between the sine and the cosecant. We know that the cosecant of theta is the reciprocal of the sine value. So we can write this as the square root of 29/5. In a similar relationship, we have the cosine as it relates to the secant. And we can simply take the cosine value and reciprocate that. From this, we get the square root of 29 all over 2. Put the negative up on top there. And finally, the cotangent. The cotangent is the reciprocal of the tangent function. And from this, we obtain a negative 2/5. So here are our 6 trigonometric functions for this problem.